We often need to store in memory a list of elements which hold the same type of information with different values stored. For instance, the travel agency might need to carry out operations with a group of customers who share a common feature. Or, we might be asked to process information about specific data on a group of tourist attractions. And this could mean that we must load the lists in memory temporarily. To solve this kind of requirement, we must create a structure in memory capable of storing a collection of elements. We've seen that structured data types, as SDT customer in this example, enable us to define structures that store several data. In this graphical representation, we are then storing in memory the identifier, the name, and the address of one customer. To store several elements with customer data, we saw that we need to define a structured data type and indicate that it's a collection. Now let's go to GeneXus to implement a new requirement requested by the travel agency. The travel agency is willing to provide its customers with a ranking of countries based on the number of tourist attractions offered. This means that we must show all countries, sorted from larger to smaller, in what refers to number of attractions offered. To solve this requirement, we must first load all the countries stored in the database in a structure, each with its corresponding number of tourist attractions. And then we will have to sort them according to that number from the greater to the smaller amount to then show them either on a web panel or a listing. Let's then start by creating a new object of the structured data type, which we will call SDT countries. For each country, we need its identifier, its name, and number of tourist attractions registered for it. So, we have country, attractions, quantity. With this definition, we indicate that we will be saving in memory the information relative to one single country. But we need to design a ranking of countries, so we must store several countries. Then, we check the Is Collection box to have a structure that will allow us to store data of several countries. Now this structure includes the same members we defined at the start, though grouped into a substructure called SDT countries item. This substructure was automatically created when we indicated the collection checkmark. Each item will store one country's data, and the group of items with countries comprise the collection. To load the data of the collection, we will use a data provider object. The data provider object enables us to load a data structure, for example, based on data from the database, and it returns the loaded structure. Let's then go to GeneXus to create a data provider object. We select the data provider type and use the name DP ranking countries with attractions quantity. We can see that GeneXus positions us in the source section of the data provider. And here is where we will declare how we want the data to be loaded in the collection we want returned. Note how easy it is to declare the load. Let's go to the window of the Knowledge Base Navigator and find the structured data type SDT countries, then drag it to the source of the data provider. We can see that GeneXus automatically wrote several lines of text. If we now see the properties of the data provider, we will see that GeneXus assigned the name of the SDT countries collection to the output property. This means that the data provider will return a collection of the structured data type SDT countries loaded with data. Since the SDT countries is already a collection, we will not need to configure the collection property of the data provider with the true value. We would have to do this if we wanted the data provider to return a collection based on a simple structured data type. Now let's analyze what GeneXus wrote in the source. We recognize the name of the structured data type SDT countries that is a collection. And inside, the substructure of the collection's item is between brackets. Let's compare this to the structure of the SDT. We can see that GeneXus represented, as text, the structure of the SDT countries, and provided members ID, name, and country attractions quantity from the SDT countries item substructure for loading their values. Since we will be loading this collection based on the contents of the country table, we must indicate to the data provider that it must go over that table. To do this, we use the from clause, and next to it we include the name of the transaction whose base table we want to go over. In our case, from country. When the transaction has more than one level, in order to specify a level associated to a particular base table we want to navigate, we must write the name of the transaction, dot, and the name of the level. So now, let's indicate that we want to load the ID element with the value of the country ID attribute. While the name member will be loaded with the value of country name, and member country attractions quantity is to be loaded with the number of tourist attractions that each country has. So we assign to this member the result of the formula count attraction name. Let's review a concept that we've already seen. This inline formula defined will navigate the attraction table by the attribute indicated inside the parentheses. Also, since there is an attribute in common between the tables navigated by the data provider and the formula, that is, country ID, then the formula will count the attractions of the country navigated by the data provider every time. So, what we did was simply declare one table to be navigated by the data provider, and for each record accessed, we indicated the values we want to assign to a new item in the collection of countries. Since the data provider goes over the country table, we usually say that the base table of the data provider is country. The final outcome will be that the collection in memory will store the data of all the countries in the database, each with its own number of attractions. We save the definition of this data provider, and we now create a procedure object to view the contents of the collection of countries. We call this procedure print ranking. Now we go to the variables section of this procedure and define a countries variable of the SDT countries data type. Then we go to the source, write ampersand, and select our countries variable, and we will load this variable of the collection type, assigning to it the result returned by the data provider we just created. So, we write the equal sign, and we drag the data provider from the Knowledge Base Navigator window. To end this instruction, we add the parentheses. With this instruction we wrote, we are invoking the data provider, which will return a collection of countries that will be loaded in the countries variable. Now, let's recall the exact requirement of the travel agency, to view a ranking of all countries sorted from greater to lesser number of recorded attractions. So, what is left to do is sort the collection we obtained loaded. That is, sort the items of the country collection prior to showing it, in order from the greater to the lesser number of attractions recorded. To solve this, we have the sort method, and the syntax is as follows. The countries variable dot sort, and inside parentheses and quotation marks, the name of the SDT member by which we want to sort. In our case, country attractions, quantity. But this will sort the country collection from lesser to greater number of attractions, and we need the opposite sorting because we need to implement a ranking. So, to indicate the reverse order, inside the quotation marks, we add brackets. The only thing remaining now is to go over the collection again with the data provider and print each item in it with the stored data. To go over a collection stored in memory, we have the for_element_in_collection command. Now we'll define a one_country variable to load in it each element we iterate from. The data type will be SDT countries dot SDT countries item. Now let's go back to the source to complete the code that will go over the collection. We write for one country in countries, print the print block called country, and close with end for. Now let's go to the layout section and call this print block country. We select Insert, Variable, and select one country. Locate the controls in the print block. And all that's left is to define the properties required to print the listing in PDF format. So we go to the procedures properties and indicate for main program the value true, call protocol with HTTP, and lastly insert the output file rule and name the listing file as ranking PDF. And PDF format. The development of the requirement is now complete. We select Run over the procedure to view the ranking in runtime. And we view the PDF listing with all the countries stored in the database, each with its own number of attractions and the order of countries as requested. So, we've seen the power of data providers to load data in a data structure in memory, specifically in the case of collection type. And we saw how simple it is to declare what we wanted to load, where GeneXus solved everything needed to carry it out. Data providers optionally admit the where clause to filter, like the for_each command. Further ahead, we will see other examples where data providers are used. They may also be invoked in other object sections, such as in web panel events. And to end, we update changes in GX Server.